Hey guys, so in this example, we're asked to find the zeros algebraically, use a graphing utility to graph the function, and then use the graph to approximate any zeros and compare them with those from part A. So as you can see, our function is g of t. Let's see if I can get my mouse going. There we go. G of t equals t to the fifth minus 6t cubed plus 9t. So with each one of these functions, there's going to be different methods you're going to have to use to break them down. Sometimes you may be given a quadratic, and you can factor that as you would factoring a quadratic trinomial. Sometimes you may have a difference of squares. Sometimes you may need to take the GCF out first. Sometimes you may use grouping, and so on. It all depends on what you're given. So in this case, the first thing we can do, since they all have at least one t, we can factor out a t, and that leaves us with t times t to the fourth minus 6t squared plus 9. So what we have left in parentheses is of quadratic form. So what we can do is find two numbers that multiply to be 9 that add to be negative 6. So that would be negative 3 and negative 3. And then since this is degree 4, we need these exponents to be half of that. So as I said, we're going to use negative 3. So we have t squared minus 3, and then we have another t squared minus 3. Okay, again, one more time. Negative 3 times negative 3 is positive 9. Negative 3 plus negative 3 is negative 6. And then we take half of our highest exponent, which is 2. Okay, so neither one of these is a difference of squares. This is as far as we can factor it. So what we're going to have to do now is set each one of these factors equal to 0 and solve. All right, now setting t equal to 0, of course, there's nothing to solve. We just see that the value of t is 0. And then t squared minus 3 equal to 0, we will need to solve this. So we can add 3 to both sides. That leaves us with t squared equals 3, and then the inverse operation of a square would be to take the square root. That'll leave us with just t rather than t squared. So after taking the square root of each side, we have t equals plus or minus the square root of 3. Okay, now since we have two of those, t squared minus 3. If we solve this one, of course we're going to get the same exact thing. T equals plus or minus the square root of 3. And we just call these a multiplicity of 2. So we have positive square root of 3 twice, so it has a multiplicity of 2. And then we have negative square root of 3 twice, so negative root 3 also has a multiplicity of 2. So altogether, whatever your highest exponent is, that's the total number of roots that you have. And this does give us all 5. 1, 2, 3, 4, and 5. All right. Next, we're going to use a graphing utility to graph this function. You, of course, should use your graphing calculator to graph it. I used desmos.com, which showed me that the zeros, or the x-intercepts, are at negative 1.7320, 0, 0, and then 1.7320. And then part C tells us to use the graph to approximate any zeros, which I just did, and compare them with those from part A. So part A told us we should have a 0 at when x is 0, so that's here. And then we should also have x-intercepts at plus or minus root 3, and negative 1.732 and 1.732 do represent the positive and negative of the square root of 3.